Hello, in this lecture I will answer two questions. The first question, we find out the radius of this circle, and the second question, we find out the area of this ring shape. So we start with the first question. In the drawing we have a circle. This is the current standpoint point A. From the current standpoint point A, we have two tangents to this circle, tangent AP and tangent AQ. And in addition, we have also tangent BC. Is equals to 14 units in its length, and tangent BC is tangent to this circle at this point. So we define the point of tendency of tangent BC with this circle. This point is point M. In addition, we know that AC equals to 18 units in its length, AB equals to 16 units in its length, again, BC equals to 14 units in its length. So, the next step, we focus in this current standpoint, point B. And we define the length of line segment PB as x. From this current standpoint, point B, we have two tangents to this circle, tangent BP and tangent BM. For the two are equal to each other. This is say BP equals to BM. But BP equals to x, therefore BM must be also equal to x units in its length. So I'm pretty quickly on rule 2. According to rule 2, the lengths of two tangents for a current standpoint to a circle are equal. So in the drawing, we have a circle. This is the current standpoint point P. For this current standpoint point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule 2, they are equal to each other. That is to say PA equals to PB. And when we implemented rule 2, this current standpoint point B. For this current standpoint point B, we have two tangents to this circle, tangent BP and tangent BM. And according to rule 2, they are equal to each other. That is to say BP equals to BM. But BP equals to x according to our definition. Therefore, BM must also equal to x units in itself according to rule 2. What is the length of this line segment MC? For the drawing, it is very easy to see that MC in total equals to BC minus BM. And MC equals to BC minus BM. So it is all. This line segment MC equals to BC minus BM. So MC in total equals to BC, that is 14 according to what's got. You understand the question? Minus BM. BM is x. So total we found out that MC equals to 14 or 6 units in its length. This is the AC line segment MC. That equals to 14 or 6 units in its length. In the next step, we implement rule 2 at this current standpoint point C. From this current standpoint point C, we have two tangents to this circle, tangent CM and tangent CQ. And according to rule 2, they are equal to each other. That is to say CM equals to CQ. But CM is 14 minus 6, therefore CQ must be also equal to 14 minus 6 units in itself according to rule 2. is equals to 14 on 6 according to 1, 2. In the next step, the focus in this character point A. For this character point A, we have two tangents to this circuit, tangent AP and tangent AQ. And according to what they are equal to each other, that is to say AP equals to AQ. So you know, so if you focus at the character point A, for character point A, we have two tangents to this circuit. Tangent AP and tangent AQ, and according to what they are equal to each other, that is to say AP equals to AQ. AP equals to x plus 16. So it is on. For the moment, it is very easy to see that AP equals to x plus 16. And it equals to AQ. For the moment, it is very easy to see that AQ in total equals to 18 plus 14 minus 6. Again, AQ equals to 18 plus 14 minus 6. AQ equals to 18 plus 14 minus 6. So if you know that AQ equals to 18 plus 14 is 32 minus 6. Okay. So in total, if you know that those two sides of the equation are equal to each other, that is to say x plus 16 equals to 32 minus 6. Here we subtract 16 from this equation. So this side of the equation, 16 will get cancelled, and left over with x equals to 32 minus 16 is 16 minus x. So in total, if you know that x equals to 16 minus x. Here we add x to this equation. And we get that x plus x is 2x equals to 16. X minus x is 0. So x minus x is 0. So x equals to 16. Here we divide this equation by 2. And find that x equals to 16 over 2, that is 8. X equals to 8 units in its length. PB equals to x and x equals to 8. So as you know, PB equals to x equals to 8 units in its length. Likewise, BM also equals to x and x equals to 8 units in its length. Here we have MC equals to 14 minus x. 14 minus x is 14 minus 8, and 14 minus 8, that is 6. So MC equals to 6 units in its length. Likewise, QC also equals to 14 minus x, that is to say, is equal to 6. In the next step, we join point A, we define the center of this circle, this point is point O, and we join points A and O together by a straight line. In the next step, we will join points O and Q together by a straight line. Point Q is the point of tendency of tangent AQ with this circle. Repeat again. Point O is the center of this circle. Point Q is the point of the circle itself. Therefore, OQ is the radius of this circle. The radius of the circle is the radius that we are looking for in this question. So we define the radius OQ as R. OQ equals to R. This is the radius of the circle. The radius of Q is equals to R. The radius of Q is known to point Q. That is the point of tendency of tangent AQ with this circle. Remember, your radius that is known to the point of tendency, then tangent AQ will be perpendicular to the radius QO. If AQ is perpendicular to QO, it means that this angle equals to 90 degrees in its size according to rule 1. Likewise, we will join points O and P together by a straight line. Point P is the point of tendency of tangent AP with this circle. So OP is the radius of this circle. That is equals to R. According to our definition, OP equals to R. The radius of P that is equals to R. The radius of P is known to point P. That is the point of tendency of tangent AP with this circle. Whenever your radius that is known to the point of tendency, then tangent AP will be perpendicular to the radius PO. If AP is perpendicular to PO, it means that this angle equals to 90 degrees according to the same rule, rule 1. When doing all those constructions, we can do two right triangles. We have the big right triangle APO. We have the small, the right lower triangle AOQ. And again, this is the upper right triangle APO, and this is the lower right triangle AOQ. So, what is the area of this quadrangle APOQ? The area of quadrangle APOQ this big quadrangle APOQ must be equal to the sum of the areas of the two components that it consists of. The first component that it consists of is the right triangle APO. So it is the area of the right triangle APO plus the area of the first component that quadrangle APOQ consists of. The second component that the big quadrangle APOQ consists of is the right lower triangle AOQ. So if you found out that the area of this big quadrangle APOQ is equal to the sum of the areas of the two components that it consists of. The first component that it consists, the quadrangle APOQ consists of, is the right triangle APO. So this is the area of the right triangle APO, plus the area of the second component that quadrangle APOQ consists of, is actually triangle APO. So it is plus the area of the second component, that is the area of triangle APO, the right triangle APO. So the area of the big quadrangle APOQ is equal to the area of the upper right triangle AOP. The area of the upper right triangle AOP equals to the base AP times the I to the base, that is PO over 2. Again, the area of the first component that the quadrangle APOQ consists of is the area of the upper right triangle APO. The area of the upper right triangle APO equals to the base AP times the height of the base PO over 2. Plus the area of the second component that quadrilateral APO Q consists of is actually the area of the lower right triangle AOQ. The area of the lower right triangle AOQ equals to the base AQ times the height of the base that is QO, because it creates 90 degrees with the base. So this times the height of the base QO over 2. So if we found out that the area of the second component that quadrilateral APO consists of is the area of the right triangle AOQ. This equals to the base AQ times the height to the base QO over 2. So the area of quadrilateral APOQ is equal to AP times PO over 2. AP is 16 plus 8, that is 24. Times PO. PO is R over 2. So in total we found out that the area of this upper right triangle OPA equals to 24R over 2. Repeat again, the area of this upper right triangle OPA is equal to 24R over 2. Plus the area of the second component that quadrilateral AP or Q consists of, that is actually the area of this right triangle OQA. The area of the right triangle OQA equals to the base AQ. AQ equals to 16 plus 6, that is 24. Again, AQ total equals to 16 plus to 18 plus 6, that is 24. Times QO. QO is R over 2. So total we found out that the area of this big quadrilateral APOQ equals to 24R over 2 is 12R, plus 24R over 2 is also 12R. 12R plus 12R is 24R square units in its size. And again, in total we found out that the area of the big quadrilateral APOQ is equal to 24R square units in its size. So according to the first method of calculation, the area of this big quadrilateral APOQ is equal to 24R square units in its size. In the next step, I will delete the straight line of OA. Again, I will delete this straight line OA. And we'll join points O and M together by straight line. Repeat again, we'll join points O, that is the center of the circle, with point M, that is the point of tendency BC with this circle. Point O is the center of this circle, point M is the point of the circle itself, therefore OM is the radius of this circle. This goes to R. The radius OM that is equals to R. The radius OM is drawn to point M, that is the point of tendency BC with this circle. And whenever your radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius MO. If BC is perpendicular to MO, it means that this angle equals to 90 degrees in size. And this angle also equals to 90 degrees in size according to the sum over rule 1. In the next step, we will join points O and B together by straight line. Likewise, We will join points O and C together by a straight line. By doing those constructions, we can do 4 small right triangles. 1, 2, 3, 4. So what is the area of those all 4 right triangles? The area of this upper small right triangle OPB is equal to the base PB times the height of the base, that is PO over 2. So it is the base PB is 8 times the height PO, that is R over 2. 8R over 2 is 4R. Again, 8R over 2 is 4R. So the area of this upper small right triangle OPB is equal to 4R square units in its size. Likewise, what is the area of this right small triangle OBM? The area of this right small triangle OBM equals to the base BM, that is 8, times the height MO, that is R over 2. So total, the area of this triangle the area of this triangle right triangle OBM equals to MB, that is 8, times OM, that is R over 2. So total, the area of triangle OBM equals to 8R over 2. 8R over 2 is 4R. So the area of this right triangle OBM also equals to 4R square units in its size. Exactly like this right triangle QPB, that also equals to 4R square units in its size. What is the area of this triangle OMB, the right triangle OMC? The area of this right triangle OMC equals to the base MC, that is 6, times the height MO, that is R over 2. So in total, the area of this right triangle OMC equals to 6R over 2. 6R over 2 is 3R. The area of the right triangle OMC is equal to 3R square units in its size. And finally, what is the area of this right triangle OQC? The area of this right triangle OQC equals to the base QC, that is 6, times the height QO, that is R over 2. So in total, the area of this right triangle OQC equals to 6R over 2. 6R over 2 is 3R. 3R square units in its size. So if we found out the areas of those all 4 right triangles, 4R plus 4R is 8R, 8R plus 3R, 8R plus 3R is 11R, 11R plus 3R is 14R square units in its size. So in total, we found out that the sum of the areas of those 4 right triangles is equal to 14R square units in its size. So in the next step, so the only missing part that we have in order to find out the area of this quadrangle APOQ is this triangle ABC. So there, so in total, the area of quadrangle APOQ will be equal to 14R. That is the sum of the areas of those 4 right triangles plus the area of this missing triangle ABC. So it is now that we found out that the area of this big quadrangle APOQ is equal to, according to the second method of calculation, the area of the big quadrangle APOQ, according to the second method of calculation, is equal to the sum of the areas of those 4 right triangles. That is actually 4R plus 4R is 8, 4R plus 4R is 8R, 8R plus 3R is 11r plus 3r is 14r squared in size. So it is the sum of the rest of those four right small triangles, that is 14r plus the area of this triangle ABC. Repeat again, the area of this big quadrangle AP or Q is equal to the sum of the rest of those 5 components that it consists of. The area of those 4 components is 14r plus the area of the 5th component that it consists of, the area of this triangle ABC. So the only missing part that we have in order to find out the area of this quadrangle AP or Q, according to the second method of calculation, is the area of this triangle ABC. So what is the area of this triangle ABC? Actually, we use this special formula that is true for any triangle. The area of any triangle equals to the square root of S times S minus A times S minus B times S minus C. Repeat again, the area of any triangle ABC could be any triangle, is equal to the square root of S times S minus A times S minus B times S minus C. S is the semi-perimeter of this triangle ABC. S is the semi-perimeter of this triangle ABC. And what is a semi-perimeter? A semi-perimeter is a perimeter over 2. And the perimeter of this triangle ABC equals to the sum of its 3 side lengths. That is to say, it is 16 plus 14 plus 18. The perimeter equals to the sum the side lengths, the sum of the side lengths of triangle ABC. This is equals to 16 plus 14 plus 18. And if we divide the perimeter to 2, we get the semi-perimeter of this triangle ABC. So the semi-perimeter of this triangle ABC equals to 16 plus 14 is 30, and 30 plus 18 is 48 over 2. 48 over 2 is 24. So today we found out that the semi-perimeter S of triangle ABC is equal to 24 units in its length. So S equals to 24 units. A, B, and C are the side lengths of triangle ABC. Again, A, B, and C, this equation is the side lengths of triangle ABC. So we will define the length of AB, that is 16, as A. So A equals to 16 according to our definition. We define the length of this side BC, that is 14, as B. So B equals to 14 also according to our definition. And we define the length of this side CA of this side ABC, that is equals to 18 as C. So C equals to 18. We actually have all the data that is needed in order to find out the area of this triangle ABC. Just have to put this data of our triangle ABC inside this general formula for the area of any triangle, and this way we find out the area of this triangle ABC. We'll do it now and get that the area of our triangle ABC is equal to the square root Here we have S. S is 24 times S minus A. S is 24, A is 16, so it is 24 minus 16 times S minus B. S is 24, B is 14, so in total S minus B is 24 minus 14 times S minus C. S is 24, C is 18, so in total S minus C equals to 24 minus 18. All inside the root. So in total, if you found out that the area of triangle ABC, the area of our triangle ABC, according to the formula, is equal to the square root of 24 times 24 minus 16 is 8, times 24 minus 14 is 10, times 24 minus 18 is 6. So in total, if you found out that the area of this triangle ABC, according to the new formula, equals to the square root of 24 times 8 times 10 times 6. Actually, the value of this expression is equal to 107.33 square units in size. So in total, we found out that the area of our triangle ABC is equal to 107.33 square units in size. We have this triangle ABC equals to 107.33 square units in size. And in total, according to the second method of calculation, the area of the big quadrangle APOQ equals to 14R. That is the sum of the areas of the four small right triangles. Those four small right triangles, plus the area of this triangle ABC. Plus the area of triangle ABC. We just write down further that the area of triangle ABC equals to 107.33 square units in size. So according to the second method of calculation, I should found out that the area of this big quadrangle APOQ is equal to 14R plus 107.33. This is the area of triangle ABC. Repeat again. In total, we found out that the area of quadrangle APOQ according to the second method of calculation equals to 14R plus 107.33 square units in size. Well, according to the second method, to the first method of calculation, we found out already that the area of the same quadrangle APOQ is equal to 24R square units in size. So in the next step, we get an equation that says that the area of quadrangle APOQ, according to the first method of calculation, must be equal to the area of the same quadrangle APOQ according to the second method of calculation. Okay, the area of quadrangle APOQ according to the first method of calculation equals to the area of the same quadrangle APOQ according to the second method of calculation. So the area of the quadrangle APOQ according to the first method of calculation equals to 24R. And it must be equal to the area of the same quadrangle APOQ according to the second method of calculation. The area of quadrangle APOQ according to the second method of calculation equals to 14R plus 107.33. So in total, we found out that 24R equals to 14R plus 107.33. Here we subtract 14r from this equation. And you get that 24r minus 14r is 10r. So 10r equals to 14r minus 14r is 0. So we're left only with 107.33. So in total, we found out that 10r equals to 107.33. R is the radius of this circle. That is the radius that we're looking for in this question. And again, R is the radius of this circle. That is the radius that we're looking for in this question. So here we divide this equation by 10. And when you get that the radius that we are looking for in this question, the radius R equals to 107.33 over 10 is 10.733 units in its length. And again, in total, we found out that the area that we are looking for in this question, that is the area of this, the radius that we are looking for in this question, that is the radius of this circle, the radius R equals to 10.733 units in its length. And again, the area of this circle equals to the radius of this circle, R equals to 10.733 units in its length. So we finish with the first question. The next step, I present to the second question of this lecture, and we listen on the second question of this lecture. In the second question, our task is to find out the area of this grain shape. Okay, so in the drawing, we have 3 semicircles. This is the biggest semicircle, this is the medium semicircle, and this is the small semicircle. And we also have this quarter circle, and this rectangle. The area of this rectangle is equal to 4 square units in its size according to what is given in the equation. And our task is to find out the area of this grain shape. Okay, so we define the width of this rectangle. This side is y. And we define the length of this rectangle. This side is x. You know that the area of any rectangle equals to the length times the width. So x times y equals to 4. Again, x times y equals to 4, because it is given as a question that the area of this rectangle equals to 4 square units in its size. So we shall find out that x times y, that is the area of this rectangle, again, equals to 4. X times y equals to 4. We also know that the opposite sides of rectangle are equal to each other. So in this rectangle, those two sides are equal to each other in their lengths. But this side equals to y, the opposite side must be also equal to y units in its length. This gives us the question that this is a quarter circle. Those two sides are the area of this quarter circle. Again, those two sides are the area of this quarter circle. But this radius equals to y, therefore this radius must be also equal to y when it's in its length. What is the area of the biggest semicircle? What is the radius of this biggest semicircle? Actually, the radius of this biggest semicircle, the radius of this biggest semicircle equals to the diameter over 2. And again, the radius of this biggest semicircle equals to the diameter over 2. The diameter of this biggest semicircle equals to x plus y. So x plus y over 2 is the radius of this biggest semicircle. Okay, again, the radius of this biggest semicircle equals to x plus y over 2 units in its length. Likewise, what is the radius of this medium semicircle? The radius of the medium semicircle equals to the diameter of the medium semicircle over 2. The diameter of this medium semicircle is x, therefore the radius is x over 2. So the radius is x over 2. And finally, what is the radius of the smallest semicircle? The radius of the smallest semicircle is equal to the diameter of the semicircle, the diameter of the smallest semicircle over 2. The diameter of this smallest semicircle is y, so the radius is y over 2. We're talking about this smallest semicircle. The diameter of this smallest semicircle is y, therefore the radius is y over 2. So, in conclusion, we can say that the radius of this biggest semicircle equals to x plus y over 2, the radius of this medium semicircle equals to x over 2, and the radius of this smallest semicircle equals to y over 2. What is the area of this green shape? From the drawing, it is very easy to see that the area of this green shape equals to the area of the biggest semicircle so it is the area of the biggest semicircle minus the area of this medium semicircle minus the area of this smallest semicircle. And again, the area of this green shape in total equals to the area of the biggest semicircle minus the area of the medium semicircle minus the area of the smallest semicircle. we already found out that the radius of this biggest semicircle equals to x plus y over 2 units in its length. The radius of this small medium semicircle equals to x over 2 units in its length. And finally, the radius of this smallest semicircle equals to y over 2 units in its length. So the area of the biggest semicircle equals to pi times the radius of the semicircle squared over 2. Repeat again. The area of this biggest semicircle equals to pi times the radius of this biggest semicircle squared over 2. Minus the area of the medium semicircle, the area of this medium semicircle equals to pi times the radius of the medium semicircle squared over 2. Minus the area of this smallest semicircle. The area of this smallest semicircle equals to pi times the radius of the smallest semicircle squared over 2. So the area of the biggest semicircle equals to pi over 2 times the radius of this biggest semicircle squared. That is to say, it is x plus y over 2 squared. So today we found out that the area of the biggest semicircle equals to pi over 2 times x plus y over 2 squared. Minus the area of the medium semicircle equals to pi over 2 times the radius of this medium semicircle squared. That is to say, it is x over 2 squared. So total the area of this medium semicircle equals to pi over 2 times x over 2 squared. Minus the area of this smallest semicircle. The area of this smallest semicircle equals to pi over 2 times the radius of this smallest semicircle squared. That is to say, it is y over 2 squared. So total we found out that the area of this smallest semicircle equals to pi over 2 times y over 2 squared. In the next step, we just simplify all those three expressions. So here we have pi over 2. In the brackets we have x plus y over 2 squared. X plus y over 2 squared equals to x plus y squared over 2 squared, that is 4. Minus pi over 2 times x over 2 squared. X over 2 squared equals to x squared over 4. Minus pi over 2 times y over 2 squared. Y over 2 squared equals to y squared over 4. So here we take a common factor of 8 from all those three expressions. In the denominator of this expression we have 2 times 4, that is 8. In the denominator of this expression also equals, we have 2 times 4, that is 8. And in the denominator of this expression equals to 2 times 4, that is 8. So we take 8 as a common factor out of those three expressions. So in the denominator we have 8. While in the denominator we have pi times x plus y squared. Pi times x plus y squared minus, in the denominator we have pi x squared. Minus, in the denominator we have here minus pi y squared. So it is pi Here we'll open the brackets of this expression. X plus y squared equals to x squared plus y squared plus 2 times x times y multiplied by pi with minus pi x squared minus pi y squared. We'll open the brackets here of this expression and you get that the numerator we have 8 pi times x squared is pi x squared times pi times y squared is pi y squared times pi times 2xy equals to 2 pi xy. Minus pi x squared minus pi y squared. So we should find out that they have the green shape, that is they have that we are looking for this question. Equal to the value of this expression. So in the denominator we have 8. In the denominator we have pi x squared minus pi x squared is 0. Pi y squared minus pi y squared is 0. So in the denominator we left only with 2 pi x squared, 2 pi xy, 2 pi times xy over 8. Here we divide both the numerator and the denominator of this expression by 2. So here 2 will get cancelled and we left only with pi xy over 8 over 2 is 4. So total we should know that they have this green shape equals to pi times xy over 4. They have this green shape. That is the other that we're looking for this question. Is equal to pi xy over 4. But we already found out that xy equals to 4. So we substitute xy in this equation by 4. And get that here we have pi over 4. xy is 4. So we substitute xy by 4. So we found out that the green shape equals to pi times 4 over 4. We have 4 in the numerator, 4 in the denominator, so 4 will get cancelled, and we left only with pi. So today we found out that they have this green shape, that is the area that we are looking for this question. Is equal to pi square units in its size. Pi square units in its size. And again, they have this green shape, that is the area that we're looking for this question. Is equal to pi square units in its size. That is the answer to the second question. So in the next step, I'm starting the lecture. We start with the repetition of the solution of the first question and then repeat of the solution of this second question. In the first question, our task was to find out the radius of this circle. So in the moment we have a circle. This is the common point A. From this common point A, we have two tangents to this circle, tangent AP and tangent AQ. In addition, we have the first tangent to this circle, that is tangent BC, that is equals to 14 units in its length. AB equals to 16 units in its length. AC equals to 18 units in its length. Again, our task is to find out the radius of this circle. So first of all, we define the point of tendency of tangent BC with this circle. This point is point M. We defined the center of this circle. This point is point O. Point Q is the point of tendency of tangent AQ with this circle. The next step, we join points O and Q together by straight line. Point O is the center of this circle. Point Q is the point on the circle itself. Therefore, OQ is the radius of this circle. That is the radius that we are looking for in this question. We define the radius of Q is R. The radius of Q is equal to R. The radius of Q is drawn to point Q. That is the point of tendency of tangent AQ with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent AQ will be perpendicular to the radius QO. If AQ is perpendicular to QO, it means that this angle equals to 90 according to rule 1. Likewise, we join points O and P together by straight line. Point P is the point of tendency of tangent P with this circle. So OP is the radius of this circle. This is equals to R according to our definition. The radius of P is equals to R. The radius of P is drawn to point P. That is the point of tendency of tangent P with this circle. Whenever your radius is drawn to the point of tendency, then tangent AP will be perpendicular to the radius PO. If AP is perpendicular to PO, it means that this angle equals to 90 degrees according to the same rule, rule 1. In the next step, we define this short line segment PB as X, and we implemented rule 2 in our drawing. Very quickly on rule 2. According to rule 2, the lengths of two tangents from a common start point to a circle are equal. In the drawing, we have a circle. This is the common start point, point P. From this common start point, point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule, they are equal to each other. That is to say, PA equals to PB. So we can actually implement rule 2 in our drawing. Why? Because in our drawing, if you focus at this common start point, point B, from this common start point, point B, we have two tangents to this circle, tangent BP and tangent BM. And according to rule 2, they are equal to each other. That is to say, BP equals to BM. But according to our definition, BP equals to X, and therefore BM must be also equal to X according to rule 2. So BM equals to X, BC equals to 14, and therefore, let me say now that MC equals to 14 to BC minus BM. BC minus BM. So MC equals to BC minus BM. MC equals to BC, that is 14, according to what is going in the question, minus BM. We just write down found out that BM equals to X. So total, let me say now that MC equals to 14 minus X units in its length. In the next step, we focus on this common start point, point C. From this common start point, point C, we have two tangents to this circle, tangent CM and tangent CQ. And according to rule 2, they are equal to each other. That is to say, CM equals to CQ. But we already found out that CM equals to 14 minus X. Therefore, that means inside CQ must be also equal to 14 minus X. Units in its length according to the same rule, rule 2. In the next step, we focus on this common start point, point A. From this common start point, point A, we have two tangents to this circle, tangent AP and tangent AQ. And according to rule 2, they are equal to each other. That is to say, AP equals to AQ. So if you follow the common start point, point A, tangent AP equals to tangent AQ according to rule 2. AP in total equals to 16 plus X. And it equals to AQ. AQ in total equals to 14 minus X plus 18. And again, in total, we found out that AP equals to 16 minus X. AP equals to 16 plus X. Yeah. AP in total equals to 16 plus X. And it equals to AQ. AQ in total equals to 18 plus 14 minus X. AQ in total equals to 18 plus 14 minus X, and it equals to 16 plus X. 18 plus 14 is 32, so this expression in total equals to 32 minus X. So in total, we found out that those two sides of the equation are equal to each other. That is to say, 16 plus X is equals to 32 minus X. Here, we subtracted 16 from this equation, and finally found out that here 16 or 16 is also in this side of the equation we have to leave X, And on the other side of the equation, we have 32 minus 16 is 16. So in total this expression equals to 16 minus x. So x equals to 16 minus x. Here we add x to this equation, and finally found out that 2x equals to 16. Here we divided the equation by 2, and finally found out that x equals to 16 over 2, that is 8. PB equals to x and x equals to 8. Likewise, BM also equals to x and x equals to 8. Here, CM equals to 14 minus x, that is to say it is 14 minus 8, that is 6. So MC equals to 6. QC also equals to 14 minus x, therefore it equals to 6. So, in the next step, we joined points A and O together by straight line. Again, we join the center of this area, that is point A, with point O, with this point A. By join points O and A, we can do those two right angles. The right angle OPA and the right lower triangle OQA. So we have those two right angles that we created by joining points A and O. And the area of this big quadrilateral APOQ must be equal to the sum of the areas of those two components that it consists of. The first component is the area of this upper right triangle APO plus the area of the second component that quadrilateral APO consists of. That is actually the area of this right lower triangle AOQ. But again, in total, the area of the big quadrilateral APOQ must be equal to the sum of the areas of the two components that it consists of. The first component is triangle APO. The area of the first component is the area of triangle APO plus the area of the second component that it consists of is actually triangle AQO. This is therefore it is the plus the area of the second component, that is the area of triangle AQO. So the area of quadrilateral APO Q equals to the area of triangle APO. What is the area of this upper right triangle APO? It is equal to the base AP times the height PO over 2. Again, the area of this upper right triangle APO equals to the base AP times the height PO over 2. And again, the area of the upper right triangle APO equals to the base AP times the height to the base PO over 2. PO is the height to the base because of the fact that it creates 90 degrees with the base AP. So in total, we found out that the area of the first component that quadrilateral APO consists of is the base AP times the height PO over 2. Plus the area of the second component that ABC consists of is actually the area of this right lower triangle OQA. The area of this right lower triangle OQA equals to the base AQ times the height QO over 2. And again, the area of the right lower triangle AQ equals to the base is actually AQ times the height OQ over 2. Again, it is the base AQ times the height QO over 2. AQ times QO over 2. So in total, the area of quadrilateral APQO equals to AP times PO over 2. AP equals to 16 plus 8, that is 24, times the height PO, that is R over 2. So in total, the area of this upper right triangle APO equals to 24 times R over 2. So the area of the upper right triangle APO equals to 24 times R over 2, plus the area of the lower right triangle AQO, that equals to the base AQ. AQ in total equals to 18 plus 6, that is 24, plus the height OQ, that is R over 2. So in total, the area of this upper right, lower right triangle AQO equals to 24 times R over 2. So the area of the second component that quadrilateral APO consists of is also 24 R over 2. So in total, the area of this big quadrilateral APOQ is equal to 24 R over 2 plus 24 R over 2. 24 R over 2 is 12 R, so it is 12 R plus 12 R, that is 24 R. So in total, we found out that the area of this big quadrilateral APOQ, according to the first method of calculation, is equal to 24 R square units in its size. In the next step, I deleted this straight line AO. I deleted this straight line AO, and we join points O and M together by straight line. Point M is the point of tendency BC with this circle. So point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius of this circle, that is equal to R according to our definition. The radius of M that is equal to R, the radius of M is drawn to point M, that is the point of tendency BC with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius MO. If BC is perpendicular to MO, it means that this circle equals to 90 degrees, and this circle also equals to 90 degrees according to the sum rule 1. In the next step, you join points O and B together by straight line, and you join points O and C together by straight line. By doing those constructions, we get here 4 right triangles. 1, 2, 3, 4. In the next step, we calculated the area of each right triangle separately. Then we join the sum, the sum of those 4 triangles. We join the areas of those 4 triangles with each other. So they have this upper right triangle OPB equals to the base B that is 8 times the height PO that is R over 2. So in total they have this upper right triangle OPB equals to 8R over 2. 8R over 2 is 4R. Likewise, they have this right triangle MBMO equals to the base BM that is 8 times the height MO that is R over 2. So in total they have this right triangle OBM equals to 8R over 2, that is 4R. Likewise, they have this right triangle OMC equals to the base MC, that is 6, times the height MO, that is R over 2. So in total, they have this triangle OMC equals to 6R over 2, that is 3R. Likewise, they have this right triangle OQC equals to the base QC, that is 6, times the height QO, that is R over 2. So in total, they have this triangle OQC equals to 6R over 2, that is 3R. So in total, the sum of the rest of those 4 right triangles is 4R plus 4R. This is 8R. 8R plus 3R is 11R. 11R plus 3R is 14R. So in total, the sum of the rest of those 4 triangles is equal to 14R squared in their sides. So they have this quadrangle APOQ according to the second method calculation equals to the sum of the rest of those 4 right triangles, that is actually 14R, plus they have this triangle ABC. And again, they have the big quadrangle APOQ according to the second method of calculation equal to the sum of the rest of the 4 right triangles, that is 14R, plus the area of the missing triangle ABC. So what is the area of this triangle ABC? We calculated, we found out the area of this triangle ABC according to a new formula. Actually, the area of any triangle ABC could be any triangle, is equal to the square root of S times S minus A times S minus B times S minus C. S is the semi-perimeter of the triangle. The semi-perimeter is the perimeter over 2. The perimeter of any triangle is the side length, the sum of its 3 side lengths. So in this triangle, you see it is 16 plus 14 plus 18. The perimeter is 16 plus 14 plus 18. So if we divide the perimeter by 2, we get the semi-perimeter. So the semi-perimeter of triangle ABC equals to 16 plus 14, that is 30. 30 plus 18 is 42. 42 over 2 is 24. So the semi-perimeter of this triangle ABC equals the semi-perimeter S equals to 24 units in its length. And again, S equals to 24. In this equation, A, B, and C are the side lengths of the triangle. Again, A, B, and C are the side lengths of the triangle that its area that we are looking for. So in our case, we choose BC that equals to 16 SA, so A equals to 16. We choose side CB as B, so CB equals to 14, therefore B equals to 14. And finally, we choose side CA of triangle ABC as C, and C equals to 18. And again, according to our choice, A equals to 16, B equals to 14, and C equals to 18 in triangle ABC, and the semi-perimeter of triangle ABC is 24 units. So we have all the data that is needed in order to find out the area of this triangle ABC. We just have to put the data in this general formula for the triangle. In this way, we find out they have this specific triangle ABC. So we did it, and we found out that the area of our triangle ABC equals to the square root of S is 24, times S minus A. So S minus A is 24 minus 16, times S minus B. S minus B is 24 minus 16, times S minus C. S minus C is 24 minus 18. So then we found out that the area of our triangle ABC equals to the square root of 24 times 24 minus 16. 24 minus 16 is 8, times 24 minus 14. 24 minus 14 is 10, times 24 minus 18, that is 6. So in total, the area of our triangle ABC equals to the square root of 24 times 8 times 10 times 6. The value of this expression in total is equal to 107.33 square units inside. So in total, we found out that the area of this triangle ABC, that is the area that we are looking for at this stage, is equal to 107.33 square units in size. So in total, the area of quadrilateral APOQ according to the second method of calculation is equal to 14R, that is the sum of the areas of the four small right angles, plus the area of triangle ABC is equal to 107.33 square units in size. Repeat again. The area of quadrilateral APOQ according to the second method of calculation equals to 14R plus 107.33. But according to the first method of calculation, they have the same quadrilateral APOQ equals to 24 times R square units in size. In the next step, we created an equation that states that the area of triangle APOQ according to the first method of calculation must be equal to the area of the same quadrilateral APOQ according to the second method of calculation. The area of quadrilateral APOQ according to the first method of calculation is equal to 24R, and must be equal to the area of quadrilateral APOQ according to the second method of calculation, and actually equals to 14R plus 107.33. So in total, we found out that 24R equals to 14R plus 107.33. Here we subtracted 14R from this equation. So 24R minus 14R is 10R, and 14R minus 14R is 0, so left only 107.33. So in total, we found out that 10R equals to 107.33. If we divide this equation by 10, we found out that the result, that is the radius that we are looking for this equation, is equal to 107.33 over 2. 107.33 over 10 is actually 10.733 units in STEM. And again, the radius of this area, that is the radius that we are looking for, is equal to 10.733 units in its length. So we finish to repeat on the first question, and the next step repeat on the solution of the second question. In the second question, our task is to find out the area of this green shape. So in the drawing, we have three semicircles. This is the biggest semicircle, this is the medium semicircle, and this is the smallest semicircle. In addition, we have this rectangle. The area of this rectangle is 4, so it's inside according to what is given as the question. In addition, we have in the drawing this quarter circle. Again, our task is to find out the area of this green shape. In the first step, we define the width of this rectangle is y and the length is x. The area of a rectangle equals to the length times the width. So in our case, it is x times y, that is 4. This gives us the equation that the area of this rectangle is equal to 4 square units in size. So in total, we found out that the area of rectangle ABC of this rectangle is equal to x times y and 4. So x times y equals to 4 according to what is given us the question. We also know that the opposite sides of a rectangle are equal to each other. So in this rectangle, those two opposite sides are equal to each other and the rest, but this side equals to y, therefore this side must be also equal to y, units in its name. This is a quarter circle. Those two sides are defined as the radii of this quarter circle. Therefore, they must be equal to each other, their lengths. But the radius of this quarter circle is y, therefore this is the radius, so this is also y. So, the diameter of this biggest semicircle, the radius of this biggest semicircle equals to the diameter over 2. The diameter is x plus y, therefore x plus y over 2 is the radius of this biggest semicircle. And again, I should handle that the radius of the biggest semicircle equals to the diameter, that's x plus y over 2. So the radius of the biggest semicircle equals to x plus y over 2 units in its length. Likewise, the radius of this medium semicircle equals to the diameter, that's x over 2. So the radius of the medium semicircle equals to the diameter x over 2. So the radius of this medium semicircle equals to x over 2 units in its length. And finally, the radius of this smallest semicircle equals to the diameter y over 2. So the radius of the smallest semicircle equals to the diameter that is y over 2. Our task is to find out the area of this green shape. What is the area of this green shape? From the drawing it is very easy to see that the area of this green shape in total equals to the area of the biggest semicircle minus the area of this medium semicircle minus the area of this smallest semicircle. Repeat again, the area of this green shape in total is equals to the area of the biggest semicircle minus the area of the medium semicircle minus the area of the smallest semicircle. The radius of the biggest semicircle is x plus y over 2, the radius of the medium semicircle is x over 2, and the radius of the smallest semicircle equals to y over 2. Therefore, the area of this biggest semicircle equals to pi times the radius of the semicircle squared over 2. Likewise, the radius of the medium semicircle equals to pi times the radius of this medium semicircle squared over 2. And finally, the radius of this smallest semicircle equals to pi times the radius of this smallest semicircle squared over 2. So here we have pi over 2 times the radius squared. So it is pi over 2, and the radius is x plus y over 2, therefore the radius squared is x plus y over 2 squared. So in total, we find out that the area of this biggest semicircle equals to pi over 2 times x plus y over 2 squared. Likewise, the area of this medium semicircle equals to pi times the radius of the medium semicircle squared over 2. So it is pi over 2 times the radius this medium semicircle squared. The radius is x over 2, therefore the radius squared is x over 2 squared. So in total, we found out that the area of this medium semicircle equals to pi over 2 times x over 2 squared minus the area of this smallest semicircle equals to pi over 2 times the radius of this smallest semicircle squared. So it is pi over 2, and the radius of this smallest semicircle is y over 2, therefore the radius squared is y over 2 squared. So in total, we found out that the area of this smallest semicircle equals to pi over 2 times y over 2 squared. Here we simplified those three expressions. So here we have pi over 2 times x plus y over 2 squared. So it is x plus y squared. X plus y squared over 2 squared. 2 squared is 4. So in total, the value of this expression equals to pi over 2 times x plus y squared over 4. We simplify this expression here. It is pi over 2, and x squared over 2 is x squared over 4. So in total, the value of this expression, after we simplified it, is equal to pi over 2 times x squared over 4. Likewise, we simplify this expression. We have here pi over 2, and y over 2 squared is y squared over 4. So in total, the value of this expression, after we simplified it, is equal to pi over 2 times y squared over 4. Here we took 8 as a common factor out of those three expressions. We have 8, 2 times 4 is 8, 2 times 4 is 8, and 2 times 4 is 8. So we took 8 as a common factor of those three expressions. So in the numerator we have 8 as a common factor. In the numerator we have here pi times x plus y squared. This is pi times x plus y squared. Here we have minus pi x squared. copy it here, minus pi square. In the first expression we have minus pi y square. So copy it here. This is minus pi y square. So in total, we found out that the area of the green shape equals to pi times x plus y squared minus pi x squared minus pi y squared. Here we open the brackets of this expression and we found out that here we have pi over 8 and x plus y squared equals to x squared plus y squared plus 2 times x times y. Minus pi x squared minus pi y squared. We open the brackets of this expression and we have here pi x squared plus pi y squared plus pi times 2xy minus pi x squared minus pi y squared. Pi x squared minus pi x squared is 0. Pi y squared minus pi y squared is also 0. So we have in the numerator only with 2 pi xy over 8. So today we found out that the area of the green shape equals to 2 pi xy over 8. We divided both the numerator and the denominator of this expression by 2. So here 2 will get cancelled, and left only with pi xy. With pi xy, and on the denominator we have 8 over 2 is 4. So in total the area of the green shape equals to pi times xy over 4. But we already found out that xy equals to 4, so we substitute xy by 4. Here we substitute xy by 4, so this expression equals to pi over 4 and xy is 4. So total the area of the green shape equals to pi times 4 over 4. We have 4 in the denominator, 4 in the denominator, so 4 will get cancelled, we left only with pi. So in total we found out that the area that we are looking for in this question, that is the area of this green shape, is equal to pi square units in its size. Repeat again, the area of this green shape, that is the area that we are looking for in this question, is equal to pi times square units in its size. Okay, thank you very much.